Right, so today's notes, solving system using matrices. So this is section 3.6. We're gonna complete the do now, or make sure you complete your do now on Canvas, and make sure you take your quiz 3.5 today. Today is super duper duper easy. It is our last section of this chapter, of this unit. So what are matrices? So a matrix is a rectangular arrangement of numbers in rows and columns. The numbers in a matrix are called elements. The number of rows are horizontal and the number of columns are vertical. Determine the dimensions of the matrix. Okay, the dimensions of the matrix are always written rows by columns. So here's an example. So you have a matrix here. It's just a set of group of numbers arranged in a square or rectangle enclosed by brackets. So it also can just be variables, which we'll learn in our next unit. Properties of matrix. So matrix, a specified number of rows and columns, right? And so when you are identifying them, it's your row by your column. So the first one that we have is a 3 by 3 matrix. So this is a 3 by 3 matrix because it has 3 rows and 3 columns. Then this guy right here is a 2 by 4 matrix. It has 2 rows and 4 columns. And the very last one over here is a 1 by 2 matrix because it has 1 row and 2 columns. Okay, so that's how you identify or classify a matrix. Now, identifying a matrix element. To identify a matrix element, you're reading the sub number. So the subscript, it tells you the row and the column that you're going to find the element in. So I'm looking for element A in row 2, column 3. So I'm going to go to matrix A, go to row 2, column 3, and what do I find? 8. That's how you read a matrix. So that would be 8. If I asked you for a 25, you're like, oh, well, there's a row 2, but there is no column, so this is undefined. No solution. It's not possible. Does that make sense? So if I ask for a 3-1, so if I'm asking this, we're 3. Make it better. A3-1, and you're gonna go to row 3, column 1, and that's gonna give us -3. And that's how you identify a matrix, an element in a matrix. Okay. So again, here we have 4, -9, 17, 1, 0. You can read the numbers yourself. If I ask you to identify element A13, so you're identifying element A13, yes, you can say A sub 13. So I'm looking for element A13, which means I'm looking in row 1, column 3. So row 1, column 3, and that's going to be 17. So A23, that's not a 23, A17, A13 equals 17. Okay, it's literally that simple. If I ask for A34, you should tell me 0. Row 3, column 4, 0. Okay, so remember A subscript RC. Okay, you can use a matrix to represent and solve a system of equations without writing the variables. Okay, this is true. However, for the sake of time, this week, we're going to do it with not by hand, but with technology. But to set it up, so how can you represent the system of equation with the matrix? You're going to make sure the system is written in standard form. So this system is written in standard form. We're missing a term, so we're going to add plus 0x because you need everything present. Okay? And then you're going to write the system in standard form. Check. Then list out only the coefficients and constants for each system. So the coefficients, 2, 1, constant, -3. Coefficients, 0, 3, constant, 5. So 2, 1, -3, 0, 3, 5. And then put brackets around it. And now you've taken your system and you've turned it into a matrix. Okay, notice how if a coefficient isn't present, I put a 1. If a whole entire term isn't present, I put a 0. All right, let's try it again. So looking here, step 1, write the system in standard form. Standard form is written. Step 2, list out only the coefficients and constants for each system. So coefficient isn't present, there's cast with a friendly 1. And so I have 2, 1, 9, 1, -6, -1. Put brackets, boom, boom, there's my matrix. Okay, let's try an even bigger one. Okay, so here, I'm going to make sure it's in standard form, which is X, Y, Z, alphabetical order, right? For X, Y, Z, constant. X, Y, no Z. So I'm going to have to insert a plus 0Z, constant. X, Y, Z, constant. Okay. Standard form check. List out only the coefficients and constants. So we have 4, -3, 5, -13. We have 1, 3, 0, 3. We have 2, 4, 3. And there you go. Coefficients and constants listed, brackets put around. And that's how you go from a system to a matrix. Okay. Writing a system from a matrix, so going backwards. So going backwards, the first step is to label your columns. So we have X's and we have Y's and we have our constant. Okay, step 2 is to re-add the variables. So we have 5x plus 2y equals 7. Next one, 0x, which means I don't have anything, plus 1y equals 9. And there, and then step 3 is to draw your brace. Step 3, the brace. Okay, step 1, label, identify columns. Step 2, write columns, write the coefficients and variables. And then step 3, draw a brace. There's really nothing else to it. Writing a system from a matrix. Double check that we're good. So these represent my X, my Y's, my constant. Gonna lead me to 2x plus 0y equals 6. 5x minus 2y equals 1. Draw my brace. And I'm done. System has been written. Okay? Any questions about going backwards? Cool, cool, cool. All right, row operations. So if we were to actually solve our matrices by hand, which we'll focus on more next unit, but there are things that you can do with your matrix. So the first thing is we can switch our rows. So you can switch any 2 rows in a matrix. That's your first row operation. It's just the switch. All right. The next thing is we can multiply a row by a constant. So if I want to change this row, I can multiply by a constant. So I can multiply this whole thing by 2. So I can do 2 times that row. And it would affect every element in that row. And then my new matrix would look like this. Okay? And then the last thing I can do is I can add 2 together. This is the thing. When you add 2 rows together, one is going to stay the same and one is going to change. So for example, I have row 1 and row 2, and I'm going to perform row 1 plus row 2. It's only going to replace row 1. Row 2 is going to stay the same. So I'm telling myself I'm going to add 1 plus 2, and it only changes row 1. When you're adding, it does not change. It doesn't change both, and it does not get rid of 1. It only changes 1 row, and the other row is going to stay the same. So the new matrix here would be 7, 0, 11, 4, negative 2, 6. Okay? So I'm going to post a video of doing solving systems with matrix by hand. I want to say, I call this right, Gaussian, I hope I'm saying that right, the Gaussian method. I'm going to post it because if you are a more math-minded individual, you may appreciate seeing it done by hand instead of by technology, which is what we're about to do. All right, so solving a system in 3 variables using matrix via technology. Okay. Remember, we've already learned elimination and substitution. Those still go to. But here's your technology option. It's actually fairly easy because not everyone has access to the TI Inspired. So we're just going to use Desmos. And so you write the system as a matrix. And then step 2, we were going to go to desmos.com/matrix. Normally, it would be us pulling out our TI Inspired and going from there. However, we're using what everyone can have access to, so we can be equitable. 3, you're going to click New Matrix and select the number of columns and rows, so input element, and then input elements and press Enter. This is going to save it as Matrix A. And then in step 4, you're going to type RREF parentheses A. What that stands for is Reduced Row Echelon Form. And basically what the calculator does, it does all the math to reduce the matrix down to its basic form. And then the numbers in the last column represent your solution, X, Y, Z. If it's a word problem, explain in terms of the problem what each variable represents. All right, so let's dive in. Let me open my matrix. Okay, so I opened it, and the first problem we're going to do together is here. So this is what is the solution of the system. So step 1 is to write this in terms of a matrix. So step 1, I'm going to write this as a matrix, which means I'm writing out my coefficients and my constants. So we have 1, -2, -2, 6. We have 2, -3, -5, 7. We have 3, 4, 1, 2. So this is my matrix. Okay. And we're all good with step 1, I'm going to assume. Now we're going to go back to Desmos. So once I type in the link, and you see where it says New Matrix, we're going to click on New Matrix. It's going to ask you how many rows and columns. So in here, we have 3 rows and 4 columns. And then we're going to input the elements. So we have 1, -2, -2, -6. And we have 2, -3, -5, -5, and 7. And we have 3, 4, 1, 2. And then we're going to enter. And there's our matrix A. So it saves it as matrix A for us. Okay. Then our next step, we're going to type RREF, which stands for reduced row echelon form. And we're going to put parentheses, and we're talking about matrix A. So we put A in the parentheses. Enter. And over here, it tells us these values. So it says our values are -8, 9, -10. So we're going to write this matrix down. So after going through the steps, we end up with 1, 0, 0, -8, 0, 1, 0, 9, 0, 0, 1, -10. Uh-oh. Okay, and so what the last column, this right here, that represents our solution. So our solution is -8, comma 9, comma -10. And there, we're done. I think I wrote those right. Let me double check. My brain's a little slow. -8, 9, 10. Yes, I did. And that's it. Okay. So I'm gonna do one more, and if you don't need it, then you don't have to hang around. But we have one more to do, and that's it. So here we have x minus 3y minus z equals -9. 3x minus 7y plus z equals -9. -2x plus 3y equals 7. We're going to convert this to a matrix. So that gives us 1, -3, -1, -9, 3, -7, 1, -9, -2, 3, 0, 7. Remember, when there's a variable missing, the element is 0. So then I'm going to take these values and repeat the process I just did. Back to my matrix. Okay, so I'm making a new matrix. Matrix B. It is 3 rows, 4 columns, and I'm going to put in my element. And my elements are 1, -3, -1, -9, and then we have 3, -7, 1, -9, and then we have -2, 3, 0, 7. Hit enter. Matrix B is saved. To find our reduced row echelon form, we're going to type RREF. This time the matrix is called B. So we're going to put B and hit enter. And it tells us our reduced row echelon form is here. So we're going to take that. I wonder if I can. Okay. 1, 0, 0, -2, -2, 1, 4, 2, 1, 4. So this leads me to 1, 0, 0, -2. I have to write it out. Okay, my solution is the last column, so therefore my solution is -2, 1, 4. And ta-da! That's it. Any questions about today's lesson?